Welcome back, Physical Science 20. This is part 2 of the section 7.4 calculations involving limiting reagents section. So the first part was looking at determining the limiting and excess reagent when we were given how many moles of each reactant we have, and then once we figure out the limiting reagent, determining how much product is produced. And we went through questions 1 and 2 in the practice. Hopefully you had a chance to do at least one of 3 and 4, maybe even both of them. Okay, the part 2 here just has an extra step, limiting reagent problems involving masses. So instead of starting off with moles and moles, what happens if we're starting off by knowing the masses of each? Really, it's not anything different, it just involves one more extra step. So for example, here methanol can be made using the synthesis reaction of carbon monoxide and hydrogen. And it says what mass of methanol can be produced if we have 9.8 grams of carbon monoxide and 1.3 grams of hydrogen. So since they give it in grams, I usually write it underneath the equation, moles on top. So 9.8 Gs of carbon monoxide, 1.30 Gs of hydrogen, and the question eventually is going to involve determining the mass of methanol. So to determine which one of these is limited, we're going to be using the mole ratio here, the 1 to 2 mole ratio. And of course, in order to use the mole ratio, you need to have these reactants in moles. Okay, so this question here, the molar mass of carbon monoxide is 28.01 grams per mole. The molar mass of hydrogen, 2.02. So they did that already here in the question, determine the molar mass, because of course to go from grams to moles, you need to know the molar mass. So here's the calculation here. So 9.80 multiplied by 1 mole over 28.01 grams, 0.34988 moles. Also carry extra digits here, we don't want to round off too soon. Hydrogen, 1.3 grams multiplied by 1 mole over 2.02, we get 0.64356 moles. Okay, and then it doesn't matter, we could either use the moles of CO and figure out how many moles of H2 we would need, or we could use the moles of H2 and figure out how many actual moles of CO we use. Doesn't matter. This example, they chose to look at hydrogen. So we take our 0.64356 mole of hydrogen, and to figure out moles of hydrogen and moles of carbon monoxide reacting, it's a 2 to 1 ratio. Starting with 2, going to 1, 0.32178 moles of carbon monoxide is what we would need. And what we have is 0.34. So we have definitely enough. We also have extra. So that tells you that carbon monoxide must be in excess, and hydrogen will definitely be using all of that up. So hydrogen is the limiting reagent or reactant as illustrated here, and that is what we're going to use to determine how many grams of methanol is produced. Okay, so if we look at hydrogen, it's a 2 to 1 ratio from that, going from there to methanol, 2 to 1 ratio. So that's going to involve 0.32178 moles of methanol. And of course, once we know how many moles of methanol, we need to figure out how many grams. And of course, that involves the molar mass, which was picked up earlier here. They don't illustrate that determination, but hopefully you can do that. 1 carbon, 3 plus 1 is 4 H's and 1 oxygen. The molar mass 32.02 moles, and we get 10.3 grams as a result. Okay? And so there's kind of a strategy that they use there, etc. I'm going to run through example practice question 1 here with you, and maybe you could do number 2 and 3. They have answers there before you go on to the assignment and do that one. Of course, you don't have answers for that one. Okay, we'll take a look here. Silicon carbide, SiC, is also known as carborundum, is a hard industrial abrasive used on grinding wheels to cut metal. Silicon carbide can be made by reacting silicon dioxide with carbon at high temperatures. So here's the equation. It says determine the mass of SiC when we have 10 Gs of SiO2 and it's combined with 7 grams of carbon. So we can see this is what I would recommend you do. arrange what you know underneath each reactant, and plan out what you're going to do. Question mark for G's here because we don't know. That's what we're going to figure out, how many grams of silicon carbide. And of course, in order to use figure out which of these we're limited in, they're going to have to be in moles first off. Okay, so of course we need to find the molar mass of SiO2 and the molar mass of carbon. So I kind of did this all over here, gang. Kind of shoved into this little left-hand area here. I tried not to make it too messy, but silicon dioxide, 1 silicon, 2 oxygens. So you can see the numbers pulled from the periodic table, 60.09 grams per mole. 1 carbon, 12.01 grams per mole. Okay, so now we know the molar mass. To figure out how many moles of silicon dioxide, 10 grams. Utilizing the molar mass, 60.09 grams is 1 mole. So of course we can cancel grams of silicon dioxide, cancels off with grams of silicon dioxide, leaving us with moles of silicon dioxide, 0.166 moles of silicon dioxide. To figure out how many moles of carbon we have, 7.0, and multiply by 1 mole over 12.01 grams. Of course the grams cancel, I'm left with moles, 0.583. Okay, so now this turns into what part 1 of this this section dealt with, comparing moles and moles by using the mole ratio. And again, it doesn't matter. We could compare this silicon dioxide to carbon or compare carbon to silicon dioxide, it doesn't matter. So for the limiting calculation, I chose silicon dioxide. I could have easily have chosen this, it doesn't matter. So my 0.16 moles of silicon dioxide will react with carbon in a 1:3 ratio. Starting with 1, going to 3. Starting with 1, going to 3. So that turns out to be 4.498 moles of carbon is required. And what I do have is 0.583. So I do have enough and more. So therefore, carbon must be excess. It's the excess reagent because I have extra of it once I use up all of the silicon dioxide. So of course the silicon dioxide is the limiting reagent. Okay, so that's the first part of this question, figuring what the limiting reagent is, because now what you can do is then figure out how much product is produced. In this case, the question asks for silicon carbide here, how many grams. So I'm going to use my limiting reagent, silicon dioxide moles, to figure that out. So 0.166, if I take a look there we go, 0.166 moles of silicon dioxide, and as we see here it's a 1:1 ratio, so that's nice and easy. Even though it doesn't change things numerically, you should still show that so you can cancel moles and moles, and we're left with moles of silicon carbide so far. And we need to figure out grams, of course, and of course that means figuring out the molar mass of silicon carbide. So another side calculation here, 1 silicon, 1 carbon, 40.10 grams per mole. So 40.01 grams per mole is equal to 1 mole, the molar mass, so that cancels with that. And then my answer will be grams of silicon carbide, which is what I want. So 0.166 times 1 times 40.1 divided by 1 and 1, 6.66 grams of silicon carbide. I apologize, it turns out to be an evil number here, or the answer here is 6.67. I got 6.66, close enough. Okay, so there you have it. So there are quite a few different steps there. These are really tricky. In fact, I think these are the most difficult examples in the chemistry unit. So if you can handle these, basically you can handle anything that's thrown at you. So 7.4 summary. In a limiting reagent problem, the amount of limiting reagent determines the amount of product. The amount of product formed, or in other words the moles of product formed, can only be predicted from the moles of limiting reagent, not from the mass. So you can see with all these, especially with the second part of this booklet, when we're given reactants in grams, we have to change it to moles so that you can use the mole ratio in the equation. And of course, figure 2 outlines the strategy here. Well, it's very similar to the strategy I outlined here, going from grams to moles, using the mole ratio, then going from there. Okay. If we take a look here at the questions, I want you to do number 1, number 2, 3, 4, 6, 7, 8, and 9. Okay? And for here, for the chart here, you don't necessarily have to show me the work. I'm just more concerned about the answers. So you must determine what the limiting reagent is first before you can figure out how much product is formed. So if I run through a couple of examples here, water is formed from hydrogen and oxygen here in a 2-to-1 ratio. Therefore, if I have 2 moles of hydrogen going from 2 to 1, 2 on the bottom, 1 on top, that gives me 1 mole of oxygen required. I have 2, so this is my excess. So 2 minus 1 gives me, I have 1 extra oxygen here. So hydrogen is my limiting reagent, oxygen is excess, so I use my limiting reagent to figure out how much product. It says here it's a 2-to-2 ratio, so 2 to 2. So you can use that reasoning if you like, or if you want, you can write down the mole ratios on a piece of scrap paper and figure it out from there if you want. If I look at this one, 0.4 moles of hydrogen, it's a 2-to-1 ratio to go to the oxygen, so 1 over 2, and of course 1 over 2 is a half, so a half of 0.4 is going to be 0.2, and look at that, I have 0.8, I have more than enough. So 0.8 minus 0.2 gives me 0.6 left over of my excess reagent. Then of course a 2-to-2 ratio, so 0.4 to 0.4. This question here at the bottom is kind of reversed. It tells you what the excess reagent is, so you kind of have to work backwards, given product, figure out how much of this you need, and then how much of this. Okay, so those are the questions. 1, 2, 3, 4, omit 5, and then 6, 7, 8, 9. Questions 1 to 6 deal with mole-to-mole calculations, so the easier ones, and then 7, 8, 9 deal with the second part here, where you're given grams and you have to convert to moles first, then use the mole ratio. Okay, once again, if you're having any problems, please see me and I will give you a hand with filling these charts or clarifying this a little bit more. Okay, we'll see you again.